Hi everyone, and welcome to this video where we will be discussing another one of the four main concepts of the Java language, polymorphism. This video will cover what polymorphism is, how it works, and why it's useful. We will see how inheritance can be manipulated using dynamic polymorphism through method overriding and upcasting. This video is for people that have at least a basic understanding with the Java language, such as understanding what classes, fields, and methods are, and what they do, as well as the use of inheritance. If you're not very familiar or comfortable with these concepts, then I suggest that you stop here and have a look at some other resources to get yourself comfortable with these ideas. So let's get a bit of background before we carry on. When we describe something as polymorphic, we mean that it's able to take on more than one form. The word polymorphic literally means many forms. In Java, this means that any object that passes more than one is-a relationship test is polymorphic. By this principle, that means that every object in Java is polymorphic in nature, as each one passes an is-a relationship test for itself, and also for the object class, which is an overarching superclass that every Java object is a child of. We know that inheritance allows us to pass functionality to one or more subclasses, which allows us to avoid code repetition and manage changes in our software more effectively. However, if in a situation we wanted to change how one of the subclasses implemented the method inherited from the superclass, how might we go about this? Well, using polymorphism, we would be able to change the method in the subclass to override the method in the superclass. This process of redefining how a superclass method works in a subclass is known as method overriding. Method overriding is a form of runtime or dynamic polymorphism, which means that the implementation of the required method happens when we run our program after it has already been compiled. Let's start with an example. Say we had a group of classes called man, woman, and child, and a superclass called person, which they all extended. The person superclass contains the method getDressed, which we want to use to tell us what the person is wearing. In this superclass, let's put something like the person is wearing clothes. At the moment, any subclass that extends this superclass and calls this getDressed method will print this message here. But through dynamic polymorphism, we will be able to adapt the getDressed method to suit whichever class the method is called on using method overriding. Method overriding refers to the overriding of a method defined in the superclass by a method with the same name and parameters in the subclass by redefining it with different implementation to the superclass. What do we mean by this? Well, if we wanted to adapt this getDressed method to suit, for example, the man class and tell us what a man is wearing, maybe a shirt and trousers, we would redefine it in the man class like so. When we create a man object in our test class and call the getDressed method on that object, we will have the new method result printed out that we've just defined, rather than the inherited superclass implementation, as we can see here. This is because when it comes to methods, subclasses get priority over their superclasses. Let's imagine now that we had a person that wanted to wear a shirt and trousers. We don't care if this person is a man, a woman, or a child. All we care about is that they're wearing a shirt and trousers. Using polymorphism, we could actually do something like this, which is create a new variable of type person, let's call it pers1, but point to a different type of object like one of our subclasses, such as man, which I'm just going to define here. Now what this says here is that we have a person, we don't care whether they're a man or a woman, all we want to do is make sure that they're wearing a shirt and trousers. Polymorphism allows us to have a reference variable, which in this case is pers1 of type person, and have it point at an object of type man. I'm going to go ahead and run that so that we can have a look at the result before I explain this in more detail. As we can see, we get the message that we defined in the man class. You might be quite surprised that we were able to do this. So because man extends person, that means in any case that the person object can be used, then the man object can also be used. This is what we call upcasting, using a subclass type in the place of its superclass. In order to understand why this works, we need to understand reference variables. Reference variables are how we're able to access objects. They tell the compiler where to find the implementation to perform a certain function on a particular object. The superclass reference variable can then access the methods of the subclass that the superclass also possesses. The subclass objects are still of the subclass type. A superclass cannot be used where a subclass is needed because it may not necessarily contain all the methods that its subclass holds. So for example, something like this, man equals new person, would throw up an error as we can see. The man subclass may contain variables that the person superclass does not, so it cannot be treated in the same way. But if we had this the other way round, we know that as a minimum, the man subclass contains all the same methods as the person superclass. So pointing to this superclass from the man subclass will not give us any problems. Let's see that with another example, using our other two classes, child and woman. Let's override our superclass method of get dressed in both of those classes. We're going to put the woman is wearing a skirt in the woman class and the child is wearing a bib in the child class. If we create a new reference variable, woman1, of type person, to point it to a woman object and call the getDressed method, we will get an output that we tailored to the woman class through method overriding, as we can see here. And if we do the same for the class named child, we can see that we get the method as defined in that class. This ability to use methods defined in objects of a different type is the essence of polymorphism. Now, you might be thinking, wow, that's really cool, but why would we want to do this and not just reference the class object that we're using in the normal way? Why would we bother going through the hassle of referencing the subclass object from a superclass variable? Well, through upcasting and method overriding, polymorphism allows us to have many objects that share the same external interface but have different internal structures. This means that as programmers, we can program for the general rather than for the specific. In doing so, changing our code later down the line and extending our programs becomes a lot easier as we can define additional classes however we want without having to adjust the code we've already written too much. Polymorphism is underpinned by inheritance, where methods and states are passed from one superclass to a subclass. To illustrate how polymorphism can help us group classes of different types together, let's look at a new example. Imagine we wanted to write a program that shows us information about different animals, like the kinds of noises they make. To start off, we could create a dog, a cat, and a bird class, each with a method makeSound. What this method can do is print out what kind of noise that animal makes. So for bird, we're going to have the bird tweets. For dog, we might print out the dog barks, and for the cat meows. Although these classes all represent animals, right now they don't have any actual connection to each other. So if we decided that we wanted to do something with all these classes at the same time or one after the other, what we would have to do is create an object for each of these classes and then call their individual methods to make them do something. But with polymorphism, all that hard work can be cut out. We can actually group the different classes together by doing something like this. Here we've stored the different types of objects in an array together, and what we want to do is go through and say, for each object in this array, do something. In our case, it would be invoke the makeSound method. But for this to work, they would need to have some way of telling the compiler that they have a relationship with each other, as at the moment, as we can see, when we try to do this, we get an error saying that they're not of the same type. Here's where our superclass comes in. Let's call it animal and put the method that they all have in common in there, which is makeSound. As we said, a superclass is the general class, so let's put something like animals make different sounds for this particular makeSound method. This acts almost as a placeholder because we will be overriding this method in our subclasses of cat, dog, and bird with their specific implementations. Now, when we extend those classes and head back to our test class, we can see that there is no longer an error as we now have something linking these classes together, our superclass. So to test this, let's use a for loop here and say that for each item in our array list of animals, call the current element's makeSound method. Polymorphism allows us to call the same method over and over, but depending on which object is being used, locate the right version of that method's implementation using our reference variable that we spoke about earlier. In this case, our reference variable is called zoo. So when we call the makeSound method on the first element of our array list of animals, our zoo variable will be pointing to a dog object. So we should get the makeSound method defined in dog. When we call the second item in our array list, our zoo variable will be pointing to a cat object. So we should get the makeSound method defined in cat, and so on. So in this for loop here, that's what I've defined. So let's run this and see if we get the correct results. There we have it. We were able to call the makeSound method and each time call the correct implementation. Being able to do this also means that if we wanted to add a new animal to our program, all we would have to do is extend the animal superclass and add it to our array list. we would not need to alter our existing code in any way to accommodate the new animal that we're adding to our array list. So that's it for this tutorial on polymorphism. Here's a quick summary on what we've covered this video. An object in Java that passes more than one is-a relationship test is polymorphic. By this principle, all Java objects are polymorphic. Method overriding is achieved through dynamic polymorphism, and reference variables allow us to achieve polymorphism through upcasting. Have a go at the following questions to test your understanding of this topic.